Okay, so I have seen students really struggle with chaining rules together. And I think the easiest way to think about it is by using like one of these web diagrams. Because when we chain things together, we have to remember that we can only go one way. We can't flip something around to force it to fit. We can't negate anything to force it to fit. So what I have here is like a really basic mock-up of some rules that may happen that you may encounter. And I want to show you how it's super easy to combine rules together when you think about it in this way. So I have my set of rules here, and I'm going to put it down here, make it a little bit bigger. Because what we're going to do is we're going to show what these rules look like, diagramming them, and then I'm going to show how to combine them together. So for example, for our first rule, we have G must be before F. So I'm going to take my variables over here. So I have one G and I have one F. Bear with me. And if G must be before F, it's not telling me that it has to be immediately before or immediately after. It's just saying it has to be some time before. So what I could do is I can draw a line, maybe, yeah, draw a line between G and F to show that G is going to be before F. I don't know if that got it. No, it didn't. So now they're connected. And what I want you to think about is when they're connected in this way, they can be pulled apart as far as possible, or they can be right next to each other. For example, they're always going to be connected, no matter how close I put them or how far away I put them. So that's what happens when you've chained them together in this way. When it gives you something like it must be immediately before or immediately after, that's where we can like combine our circles together and do G and F in one circle or something like that. But this rule is only telling me that it has to be before F. And so I'm just going to chain them, and I'm thinking of it kind of like an accordion. It can be as far apart or as close together. So that's our rule 1. Rule 2 says J must be later than K. So I'm going to pick up a J, and it must be later than K, which means that K is going to have to go before it. J is going to come after K. So very similar to our first rule, but a little bit different. And so we can join these two rules together. We can do 1 and 1 there. And so now they're very much the same as G and F. They're chained together. They can be pulled apart, or they can come together. It doesn't say who has to come for, or who has to be immediately before or immediately after any of those. But it just says that J must be later than K. So I can make J as far apart from K or as close together to K. I'm going to move you guys over here. Our next rule says H must be before F. So I'm going to look at it as a singular rule, and then we'll show how to combine them together. So if H is before F, means that H is going to come before F. Doesn't mean it has to come immediately before F, but it could if it wanted to. And so we're going to chain them up again. One chain there, one chain there. Now they're chained together. The next rule says M must be after F. So again, it's not telling me it has to come immediately after F. It's just saying that it has to be after F. I don't care when, it's just after. So, we have an M. And if it's after F, that means it's going to be on my end. And F is going to come before it. And I'm going to chain them up again. Maybe. Okay. And my last rule says J must be before F. Going over to J. Let me move these up a little bit. Okay. J must be before F. So that means J is going to come before F, and we can just chain them. Okay. So I have all of my rules as standalone rules. I haven't combined anything yet, but that's basically how we're going to form our links. Basically, think about them as our links. And so now we got to create a chain. So the easiest way to create a chain is just by overlapping your variables. And that's going to prevent you from flipping them, doing your contrapositive wrong, because a lot of people will go, okay, well, if they have to go in a certain order, I can just flip them to make them fit and whatnot. And that's not the case. We have to make sure that we keep the rule the same. And I hate contrapositives and negating things. We can totally negate some stuff and figure some stuff out from there, but it's just not worth my time. So we're going to start combining rules together. And the easiest way to combine rules together is by looking for common variables within rules. So I'm seeing F a lot in here. So I can combine my F's together. I also see two J's. That's a good place to start. I could combine my J's together, but I'm seeing a lot of F's. So I'm just going to get rid of some of those F's. And I'm going to start with my F's. Do I have all variables? Okay, I do. I'm gonna maybe shrink them, maybe not. Okay. I'm not good with spatial awareness. So we're gonna combine our F's together. And when I say you're combining your F's together, I mean, we're simply just overlaying them. So for example, I have J and F here, and I see an F and M right here. And they're going the same direction. And by that, I mean that what's coming after F and what's coming before F, think of it like a shark. It can only move in one direction. We can't go backwards. And so what I can do is I can simply overlay my F with my other F to create this one big chain. I don't know if it'll actually form a chain. Oh, it did. Okay, perfect. Easiest way to think about it is just by overlaying our variables. I kind of want to get rid of that second J there, and especially since it's already kind of overlapping it. So I'm just going to overlap my K and J with my J and F big chain. Maybe. Yeah. I'm just going to overlap that to create this. I call them like mega chains or Frankenstein rules, because what we're doing is we're combining the rules together. And we're creating this big chain. And it's really going to help us figure out where some variables can go, where some variables can't go. Because looking at it by itself, it's kind of hard to see that M, for example, was the standalone, that M must be after F. Once we start chaining them together, we can actually see that M can't go any earlier than the fourth spot at this point. And so when you're looking at just the F and M chain, it's kind of hard to see how M isn't restricted in that way. But once we have them chained together, you can clearly see that three variables actually have to come before M at this point. So now we're going to look at combining the rest of our variables, which is our F variables. Move you over there. This. So when it comes to adding on variables into like in the middle of your chain, or adding two variables into or from one variable, it's actually very simple. So what we're going to do is I'm looking at this H and F one, and I can see I have a F in my Frankenstein rule. And so what I can do is I can overlay that F. But for this fact, I'm going to make it a little bit easier, and I'm going to move my line there, because what happens is H has no correlation to K and J or M. And so even though H has to come before F, it does not have to come before M, or it does not have to come after K and J. And so what I like to do is I like to drag my H out kind of by my first variable. So that way it kind of, I don't even know if this is like the right word to use, but like it equalizes it. So it's not above or below any of the other variables, so long as it is before F. So it could be my first variable, could also be my third variable, could be my second variable, but it has to come before F. And so this is why I kind of picture them in this web diagram, is because no matter where I put F, you can see that line is always going to be attached to F. Or sorry, no matter where I put H, that line is always going to be attached to F. So I can drag H all the way out and I can still follow that line of it has to be before F. I'm going to do the same thing to G. And to make this a little bit easier, I'm just going to tack it on. And I'm going to tack it on below here. It's a lot easier in my head. Okay. So this is what my chain ends up looking like. Same thing with G as I talked about with H. G just has to be in front of F. It has no correlation to H or no correlation to K, J, M. So it can pretty much go wherever it wants so long as it is before F. And that's why we have these web diagrams, so we can think about where my variables can go, where they're restricted. Now the fun part comes in translating it. So we can make these variables all we want, but, oh, I don't have my thing plugged in. We can make these charts all we want, but it's useless if we don't know how to read it. And so the easiest way to read it is thinking about a shark. So if a question had asked me, I don't know, what could go, how many variables have to go before F, or how many variables have to go before J? I literally start at my point of F and I follow my lines and I count how many variables have to go before F. So I'm following my line J, following my line K. Now this is where I kind of divert from, I can't go backwards. While I'm not necessarily going backwards, I'm going back to my starting point. So I'm picking up my pen again, I'm going back to my starting point, and I can divert off of my second path, H. I can divert off my third path, G. So 4 variables have to come before F. Even though we don't really care about the order of them in regards to H and G, K has to go before J, but we don't really care about where those other 2 variables go. They all have to come before F in some order. And so when we look at how many variables can go before, how many variables can go after, we're following the paths that our chain is creating, and we're picking up our pen every time it drops off. So if you'll notice, I kept going after hitting J because there's something else attached to J. But when I went to H, I can't keep going because there's nothing there. And so that's where my path ends, basically. If I had, let's say O, R, S, and I was figuring out what could go after F, then I can follow my path and go M, R, S, pick up my pen again, and I can come back to M because that's where our second path diverts. I can go into O. So we're following our paths. We're not necessarily going backwards. We're just picking up our pen and going back to the beginning. One of my tricks when I'm doing a web game similar to this is I like to figure out what can go first and what can go last. And that can be really helpful because in some of these games, you may get some questions that say, how many variables can go in the 6th spot? How many variables can go in the 4th spot? Who can't go in the 1st spot? And so figuring out the ranges of our variables can be really helpful. It can also be really helpful for if you're going to put it into like an actual concrete diagram, like a 1, 2, 3, 4, 5, I'm going to order them off to the side kind of diagram rather than a web diagram. So I'm going to figure out what can go first. And that's everything that doesn't have something before it. So we kind of talked about how H and G don't have anything before it, but they could go first because it just has to be before F. We don't care about the relationship between H and K or H and J. It's not connected. So H could be one that goes first. K could be one that goes first because it doesn't have anything in front of it, and G can go first. And now I try to figure out, okay, how many can go after it? So I'm figuring out what the earliest it can go and what the latest it could go is. So looking at H, I'm going to follow my paths. So H only has one path. So I'm going to follow H to F to M because that's what's connected. That's connected to my path. So 2 variables have to come after H. And how many variables? I have 6. So that means that 2 variables have to come after H, which means that the latest that it could go is 4. So 2, 3, 4, 5, 6. I have to have 2 spaces after H. I have to make sure I have 2 spaces after H. And that means that the point where I can no longer go forward is 4, because then I'll have 8 or F and M after it. So H has a range of 1 to 4, earliest being 1, latest being 4. I'm going to figure out K. So I'm going to follow my line. So I have J after it, F after it, M after it, and nothing else because nothing comes after M. So I have to have 3 after K for sure. So that means that the latest that it could go is 3, because that'll give me 3 spaces to fill in J, F, and M. So K has a range of 1 through 3. And I'm going to figure out G. I'm going to follow my line. G is only connected to F, which is only connected to M. So you see how I'm always moving forward. I'm not going, G is connected to F, which is connected to J, which is connected to K, which is connected to M. I'm not zigzagging back and forth. I'm only moving forward. So G has 2 variables that have to go after it. So exact same as H. G has a range of 1 to 4. Now I like to figure out who could go last. And pretty easy since I didn't really attach anything onto M after it, but M is the only one that doesn't have anything after it. If you look at all of our other variables, there is a chain after that variable, which means something has to go after it. M is the only one without that. So M is our only variable that could go 6, which doesn't happen in all of the games, but it happened in my game that I made. So M is our very last variable. That's an easy thing that I could just put into the side if I wanted to. And now I can kind of, usually I don't always dive into like the middle gists of it, but sometimes it can be helpful. So if we're going to look at J and F, I could look at F and I can figure out, okay, how many variables have to go before it? 1, 2, 3, 4. 1, 2, 3, 4, which means that it has to go 5th because M has to go 6th. And if I have to have 4 before it, 4 spaces before it, it only fits in that 5th spot. Again, doesn't happen in all games, but it happened in my game. So we can put that in there fairly easy. Now looking at J, I'm going to figure out who can go before it, who can go after it. So again, we're only looking at the ones that are connected to J. So J has to have K before it, which means it has to have at least 1 variable, 1 space before it, which means the earliest that it could go is 2, because it'll allow for that or that K to go in that first spot. So earliest that J can go is 2. The latest that J can go is we're going to figure out how many variables have to come after it. And we're going to follow our chain, F, M. I'm only going forward. I can't go back. And so the reason why, I should probably clarify, the reason why I can't pick up my pen and then follow my path to H is because that's a zigzag. We're not zigzagging. We're not going backwards. We're only going forwards. If there was something that came off of F over here, like let's say I took off over there, we can totally pick up our pen and follow that path, but we can only go forward. So that means that we have F and we have M. So that means 2 variables have to go before it. We've already talked about those variables. So the latest that it could go is 4, because that allows for F and M to kind of come after it. So J has a variation of 2 to 4. And now what's really helpful is if it goes into a question of how many variables can be in my third spot, I can look at my my graph here and I can figure out who has a variation that includes a third spot. That would include H, K, G, J, because all of their ranges include that third spot. That can significantly save you time rather than trying to figure out, okay, I have K in my third spot. Could I make a world where J is in my third spot? I'm literally just counting. So simple counting, simple math can be really helpful in games. I think that's pretty much all I wanted to talk about with web games. They can be really difficult for students because they are sort of more abstract. We're not kind of looking at a table like this, like a typical ordering game is. But if you figure out your ranges, it can help you kind of form this table. So then I can go into my J. I can look to place my J. Well, J has only 3 spots, 2, 3, or 4. So I could create one world where J is in 2, one where J is in 3, one where J is in 4. And then I can fill in the rest of my variables. So K is going to have to go in 1 here. K varies between 1 and 2. And H, G, and K kind of all happen in here, not necessarily in any order. And H and G flip-flop in my other 2 worlds. So you can use a web diagram to create a more concrete diagram if that makes more sense to you. Web diagrams can be more abstract and more difficult for some students to see and move your variables around mentally. But if you think about it like we're creating this web chart kind of, and we're just overlapping and reconnecting chains, it becomes a lot more easier. So hopefully this helps. I hope that you think about chains in this way and it kind of makes more sense. So let me know if you have questions.